Hello, everyone. Welcome to another Fabric Coffee session at Microsoft Fabric Cafe. My name is Mehrdad Abdullahi, the community lead of this amazing community. Again, I'm traveling. I'm not in my ordinary office. Yeah, maybe some no lights or not that suitable, but the content is more important, of course. Without any wasting time, I'm jumping into my slides. But in the meantime, you can just write in the chat where you're connecting from. Just say hi. And I'm now located in Sydney, Australia. It's amazing, sun outside. But yeah, today, 29th session of Fabric Coffee at Microsoft Fabric Cafe, April 5th. So I'm just going through my slides. So here we are at Microsoft Learn community, a great community for all the tech related topics and contents, and where you are going to learn about Microsoft technologies and whatever that is going to be related somehow to this industry. And we have some learning rooms. There are some changes on the learning rooms. Just to stay tuned how we can connect together, on the learning rooms, and how you can connect to your experts. Uh, Here we are at Microsoft Fabric Cafe, a learning room within Microsoft Learn. That we are actually focusing only on Microsoft Fabric and whatever that is related to Microsoft Fabric. Now it is, the topics in Microsoft Fabric are expanding one by one, but we provide learning and support to Fabric users in all levels. It is a forum for everyone to learn, share, and grow skills together. In the bottom, we've got our social, links to you have a YouTube channel where you can just watch all of the the past sessions or upcoming sessions with the handler of Microsoft Fabric Cafe. Our LinkedIn page, which this QR code is going to just land you there, where we do all of our announcements, and our meetup group. Again, we do announce our events, and there you can just rate each event and being more involved actually in our community. There's a code of conduct in our community. I'm sure everyone is going to adhere to them. Thank you very much in advance. And as I mentioned, just this one. We had actually a poll regarding the suitable times for all of the attendees, all of the members to just know where you're located and what is the best time for you to have these Fabric Coffee stations. Thank you very much for your participation. For sure, for May onward, we will have the sessions accordingly. As I mentioned, if as I mentioned before, and announced on our LinkedIn page, I'm in Sydney, and we will have an in-person session, in-person event with actually hosted by Microsoft Power BI and Fabric user group in Sydney. If you're around, let's just catch up, and we can chat more and meet in person. And for April, we have 3 sessions online and 1 session in person. And for today, we have Andrew Madson with the topic of data-centric AI, accelerate success with Apache Spark, Iceberg data products. So I'm not going to waste more time. I'm gonna invite Andrew to the studio. Hey, Andrew, welcome to Microsoft Fabric Cafe. How's it going?
Thank you. Thank you for having me.
It's a pleasure for us to have you here. Uh, yeah, Andrew, I don't want to waste any time. So you're gonna share your screen for sure, and I will add it to the stage. Then I will hand over the session to you. Guys, feel free to ask your questions. I didn't ask actually, Andrew. Andrew, would you like to answer questions if there is any question comes, at the end of the session or in the middle of the session, whatever that works for you?
I'm fine either way. Whatever the flow is best. Let's do it in the middle of the session just so that we don't forget some of
If
those
there is
questions.
no problem, no problem. And yeah, that's it. Cool. I'm gonna share your screen and hand it over to you.
Awesome.
I will be in the backstage. If there's anything, I will jump in, of course. But yeah, guys, enjoy the session.
Awesome. Well, thank you so much for having me today. Just talking about a little bit about powering AI with open source data products. I appreciate the introduction. I'm Andrew Madson, head of evangelism and education at Tabico. And so, Tabico being one of the creators and maintainers of SQL Mesh, or the creator and maintainer of SQL Mesh, we're big in open source. So if you'd like to connect with me, feel free to do so and continue the conversation on LinkedIn or other platforms. Just a little bit about my background, which will help explain a little bit about how I view the data world. So I come from a data leadership background, leading large data teams and initiatives at companies like JP Morgan, LPL Financial, Mass Mutual, leading data product strategy, AI, analytics, and then moving into more of the developer advocacy at Dremio, and now leading education and evangelism at Tabico. On the side, I'm a professor. I'm a graduate professor of data science, analytics, and statistics at a bunch of different places. If you'd like your kids to get an A, have them take my course. I'm an easy grader. And then, of course, connect with me on social. Happy to continue the conversations there. I do have an open source Slack with Tabico, so feel free to join open source Slack. Tons of really good conversations there. Really deep community with lots of expertise. Any questions on SQL Mesh, open source? This is a very good place to be. One of the technologies we're going to talk about is Apache Iceberg. Dremio wrote the book on it. And so if you'd like a free copy of it, this is the link that you would use. And if you buy it on Amazon, it's like $80. It's a 350-page book. But if you'd like a free version, this is the link to get that and learn more about this deep open source technology that's really expanding rapidly. And we'll look at why here in just a little bit. Okay. Now, what's the opportunity? So you're seeing AI just everywhere. We can't get away from it. AI is just in our face every minute, every other day. It feels like there's a new, innovative, groundbreaking model. But why? Why are we hearing so much about AI? Why now? So, looking at something Jeff Bezos has said, Bill Gates has said something super similar, but we're solving problems with machine learning and artificial intelligence that we couldn't have even imagined before. Thinking about like Sora and some of these other video image generating technologies, 10 years ago, just wasn't something that we would have imagined. The MCP protocols, looking at agents, these are all things that really were science fiction to us. And now it's almost part of just daily life. And the speed of innovation with AI is incredibly fast. So Gartner just updated this statistic, which is why I've got a mismatch here because they just changed it. And I should have changed both numbers. But Gartner is reporting that 77% of organizations are ranking AI as one of their top 5 investments. And I'm a little surprised it's not even higher. But that means that, it's not just excitement around AI. There's money being put into AI to actually implement it. But why? Why is so much money going into AI right now? Like AI has been around for a while, and we'll look at that. But why are we really investing heavily in it at this moment? So, in a top-down initiative, think about, when I say top down, I mean from like the board level, executive level down, being pushed down and saying, do AI. think about like the digital transformation initiatives of, a decade ago, 15 years ago, where the push was digitize everything and move to the cloud, essentially. And that was another top down initiative. What were they looking for then in the digital transformation? They were looking for efficiency, for speed, for economic impact, or an economic moat, a competitive advantage. It's similar with AI. When we see top down initiatives, there's often a business reason behind it. So executives are looking for one, innovation, two, productivity, and like a significant increase in productivity, and also, of course, revenue and growth. When something's coming top down, revenue and growth, money's going to be impacted in some way. That's going to be a goal there. Right now, there was just a recent survey of the use cases for AI actually being implemented, not just ideas, like what are people actually doing in organizations. The number one use case was as a coding co-pilot. So think of that as like a productivity enhancement. Number two use case was automation. Again, productivity. Let's automate some rote tasks that we can get off the plate of individuals and let them be more creative or have more impact elsewhere. And the third most common use case for AI actually being implemented in organizations was as a chatbot. So that could be innovation, productivity, but you can see a lot of the initiatives that are actually being used. They're out there in the wild, they're in production, really driving at this ROI. And so that's one of the reasons that money's being put into AI at this time, is that there's executives believe that they will see an ROI versus before, where maybe the ROI was a little more ambiguous. Maybe it was more of a strategic investment and we were hoping there would be ROI on the back end. With the given capabilities of AI today, that ROI is a little more tangible. But when I say AI and when we hear AI and when we're looking at AI, what do we actually mean? So it feels a little bit like, just AI is just a blanket term these days. But I'm old enough to remember when AI was a larger, more encompassing definition, right? Some definitions, AI really includes machine learning, deep learning, neural networks, all of that. Just a few years ago, AI, when we said AI, it really was referring to deep learning. And now when we say AI, it's generally really referring to some form of generative AI. And we get so stuck on these models, or it's the shiny new object, and which is super important. Like the model does matter for sure. And this has been true for as long as I can remember. With machine learning leading ML teams, we were often, I'm guilty of this, really focused on trying to pick the best model. What's the newest model? What can we build? But we often forgot about the data, or just kind of hoped that our data, our crummy data, would be overcome by our awesome model. And we really worked on optimizing the model, doing drift analysis, making sure that we're doing CI/CD with the model and we're training it, and all of those great things that go into managing ML ops. But we were leaving the data on the back end, doing very minimal maintenance to it. It definitely did not have as robust a process to maintaining and improving it as the model had in all of the AI teams that I've led. And I've since, repented of this and realized much more fully that a successful AI system requires, one, a robust model, of course, but two, just as robust data management, because the two together are the system. And if one is lacking, then the AI system is not going to be sustainable. And unfortunately, I learned that the hard way with some AI systems that had some data issues. And so now you'll hear me preach about the AI system being the data and the model forever. But how can we see this? In a really good example, I get this image. I should put a citation on there. I apologize, I didn't. It's from a paper from Texas A&M and Rice University, showing a little bit about how GPT-1 progressed to GPT-4. over time. And if I never played with GPT-1, but I understand it was difficult to use and the value was not that great. But for the time, it was really an innovative model. So GPT-1 trained on 4.8 gigabytes of raw, unfiltered data. What can it do? It can do a little bit. It can do some natural language processing. Awesome. We get to GPT-2. We've expanded the data and improved the quality of the data, 40 gigabytes of human manually filtered data. What can we do now? We can start doing some more impressive things. We can do some math. We can do things that we definitely could not have done before. We get to GPT-3. We're almost to the turning point. How did we get there? 570 gigabytes of data filtered, heavily filtered, curated down from 45 terabytes of raw data. So this heavily curated data gets us to 3. And then we moved to ChatGPT and GPT-4, which was, in my opinion, really the turning point for when the public at large saw the utility in generative AI and really started imagining all these great use cases for it. And now we can see that we can interact with it much more fully. It can do many more tasks, and it's got the highest quality data, really human demonstrations, labeling, annotations. What got us there? You can see it on the left of this graphic, similar model architectures. These are transformer models. You know, they did tune them, they improved them, but there was no new innovation in models to get from 1 to 4. So what happened? We expanded the quantity and the quality of the data. OpenAI expanded the quantity and the quality of the data to move from GPT-1, really just very basic natural language processing, to GPT-4, insanely useful. And it's the same with our AI systems and really ML systems in general, that yes, the model matters. The architecture matters. We definitely need to match the appropriate model and architecture to the problem in a scalable, sustainable way. But just as important, the data quality and quantity need to match the robustness of that system. I love Don Knuth, the father of analysis algorithms. Premature optimization is the root of all evil. And I'm victim of this, or a perpetrator of this, in that I often try to optimize my model before I've really got the system up and going, really tested that I've got my data system in place to appropriately align and support my model, especially with AI. If you think about AI, what's the big deal? We've been hearing about this drumbeat of, get your data in order forever. Why does AI matter now? Well, think about the human in the loop. If we have kind of subpar data in an analytics workflow, we've got a lot of hands on this workflow. We've got the software engineer who's dropping the data in a data storage. Then we've got a data engineer probably moving through a medallion architecture, doing ETL, hands-on. We landed in a gold layer. Now we've got a data analyst, hands-on, analyzing the data, putting it in reports and dashboards, looking at it there, and then providing insights to the business stakeholder. A business stakeholder, hands-on, probably exported to Excel, unfortunately, but that's what we do. Is then looking at the data and trying to figure out what kind of insights can I take. They're using their business context to make those decisions. That's a lot of hands along the way. Can poor data throw off analytics and definitely cause harm? 100%. But there's a lot of humans and checkpoints along the way, from data creation to data consumption and utilization. Think about the AI workflow. Depending on the type of AI, we have the data being created and dropped in a data storage, similar to how analytics begins. But from there, depending on the model, we have the training pipeline, right? There's some hands there. We've got the data engineers, the AI engineers curating some data, training the model, and now we have the inference pipeline on our newly trained model, and it's just running. Hopefully, we have some guardrails in place, but if we've got a chat bot going or we've automated things, um, human has been pushed further out of the loop, and things may go wrong before we're able to catch it quickly. Where with an analytics pipeline, we're going to catch that fairly quickly because of all the hands in the loop. So the ability for AI to scale quickly and the human being removed from the loop, at least the later parts of that, the value chain for data, it creates much more risk. So the data is insanely important for building a sustainable AI system because the risk is so high. I think we can all think of different AI disaster tales, not to name names, but there's definitely been AI which is messed up in healthcare, in providing welfare, um, in another country, in messing up house pricing models. Um, that significant impact financially, but also human impact. So Gartner just updated this, and take Gartner, take it or leave it, but it's a source for their estimates. Anytime I see a statistic that ends in like a 0 or a 5, I'm immediately suspicious. But this is the statistic they give. So 60% of generative AI projects will be abandoned specifically because of data quality. Sorry, I was just reading one of the messages. So up until a couple of weeks ago, Gartner was saying that 60% of AI projects in general would be abandoned, and 30% of those because of data quality. But just a couple months later, with more AI projects rolling out, they're able to see more data. They've upped it that 60%, so doubled the percentage of projects that are going to be abandoned because they missed their SLAs, and because of data quality. So what's the problem? So how did we get here? So if you've worked in data longer than 5 minutes, we've got data silos, poor data quality, lack in data governance, limited data access, insufficient metadata. And Sumesh, I'll answer your question. I just saw it pop up. Since I just left Dremio, I no longer have access to my demo. So I apologize. Otherwise, I could be hands-on with Dremio and showing Apache Iceberg. But since I no longer work there, I don't have access to the system anymore. So I can talk about it and explain why it matters, and describe what you would do with it. But the hands-on demo won't be happening today, to be clear about that. But I can definitely point you to videos where either I've done it or my colleagues who are still at Dremio have done it. So if you've been in data, longer than 5 minutes, you know that there's data silos, poor data quality, lack of governance, insufficient metadata, limited data access. And why is that? And it's very frustrating being in data engineering, getting requests in and trying to figure out where's the right data, having multiple sources of truth that conflict with each other. And sometimes, if you're looking for an address, so you type in address, and now there's 1,000 tables that have address and they all have different information, which one's right? It's tough to get an enterprise level view of any of that data. Enterprise level view is insanely hard to get, and there's reasons for that. Sometimes you do want walls, right? Like not everybody should have access to sensitive data, HR data. Sometimes it happens naturally with data acquisitions. You buy a new company that had a different stack, it doesn't get fully integrated, difficult to access there. So there's a lot of reasons for that. But if we look at the history, so I can talk about why Iceberg, but what I want to do is share a little bit about the history of how did we get here. I'll do this a little different than I normally do. So if you think about like the history of data storage systems, we talk about data silos and data lakes, data lake houses, but like, why do we have them? Why are there sometimes issues communicating between them? Let's take a quick look at a brief history of data storage systems and figure out why that is. Saying a brief history of data storage is a little bit like Stephen Hawking saying a brief history of time. Yes, it's going to be a nuanced view, and there's definitely stuff that's going to be left out. But in general, the overall pattern of how did we end up where we are now and what can we do about it with current technology, including a lot of open source technology, is what we're going to look at. So, data storage, traditional data storage like databases really kind of kicks off in the 50s, right? And the 60s. We've got databases, and a database is really there to support an application, right? That's it. And so we've got the app and the database, and it's on-prem, it's insanely secure. It's secure because you just don't give access to people, the 5 people who know how to use it. It's insanely hard to use, right? SQL's not a thing. But it's transactional. It's really just there to support an app. And this kind of lasts 50s, 60s. And then in the 70s, we get this paper from E.F. Codd, who describes relational databases, saying, hey, maybe instead of just one database per app, and they're siloed, they don't talk to each other, what if we could have what's called a relational database? And relational databases are still around today, where we've got keys. Like we can match up some of these tables, and then we can access more data than we could before. So now, insanely helpful, right? It breaks down a little bit of the silo, but still on-prem, very hard to use. It required specialty, and this is really still to support an app. That's what we're doing. So we're writing to the database. We're not messing with it. It's transactional. We really don't want to mess up the application. That's really the purpose of this data storage, is to provide value for an application. And then in the 80s, there starts to be a little bit of a shift. So there's a few things that happen because in 86, 87, we get, no, it's 86, I think. No, I can't remember. I should look this up. But we get ANSI SQL, right? So now SQL makes this much more available. Before, like really matching up relational databases and tables, very, very hard. It's not like the SQL today. 80s, we get ANSI SQL, super helpful. And, Bill Inman rolls out this idea of the data warehouse. He's saying instead of having all of these individual databases, floating around and probably not talking to each other, what if we could have a central repository where that data could live? And we'll call that a data warehouse, right? We can put it all in there, and it'll be for the purpose of analytics, for reading. Because up until then, right, we've really got writing. And, in the 70s and the early 80s, we started gathering so much data, and we wanted to make more use of it, right? Like we're storing it, we're gathering it, let's make the best use of it that we can. And so we really wanted to try to figure out analytics, but the primary purpose of this data storage was not analytics. It's to support the application. So often at night, they would run the analytics workflows to try to figure out, what was going on. It's not working, right? It's really transactional. It's right. It's reading is going to mess it up. not really working. So now in this new system, what they can do is have transactional and OLAP, right? OLTP and OLAP. So we can have still our transactional databases supporting the app. And then we can do this ETL process into the warehouse so that we can do analytics. And Bill Inman's idea really was like, let's get a central repository for this data so that we can aggregate it and do analytics, right? If you think about analytics and what the purpose and value is of it, the more data you curate over time, the more value you're going to get from analytics, and from the more sources and quantity that you have in the warehouse, the more value you can have. It makes sense, right? You can just do more analytics. But what happened in the 80s, in the 90s, different business units said, oh, that warehouse is awesome. I want my own warehouse. So now we're taking ETL and now we're starting another warehouse for sales, and we're doing another warehouse for HR or marketing. And so the idea of a central repository really kind of got blown up in the implementation of it. And a little more exasperated in a different use case in the 90s, because then you start seeing data marts. Ralph Kimball rolls out the idea of data marts, which was awesome. And the purpose of a data mart really was the idea of, okay, well, marketing, sales, they really don't need each other's data in this hypothesis. And they're running analytics. They want them to be super fast. They don't want a giant table to be super slow. What if they just had their own data available to them? And we'll call that a mart. So highly curated for a specific purpose, a business unit. But now think about the issues of a mart, and we're dealing with a little bit of this now. Now we've got data silos. We've got multiple sources of truth. There's tons of inconsistencies, right? Because if we've got the database and we're doing an ETL into this mart, and we're doing a different ETL into this mart, who knows what the assumptions were, the timing, all of these things. So we start to see the data quality sometimes be a big challenge. It's definitely a challenge to manage in these marts. Data governance was a challenge because now we've got disparate data systems, a much larger data estate. And so, I mean, as I'm saying this, you're like, we still have that. Yeah, we still do. And this is why, because we're evolving these data architectures. And then, in the 2000s, right? So the warehouse and the mart patterns continue in the 2000s. The internet boom. We start seeing data lakes. So now we've got the internet, and besides just rows and columns, all this structured data, which is in warehouses, need to be structured, marts need to be structured, and that's still relatively true today. But now we've got all this other data coming from the internet, lots of unstructured data. Well, how do you store that? We get the data lake. And data lakes are awesome because now we don't just have to have rows and columns. We can do object storage. We've got Hadoop on-prem. We start seeing clouds roll out. I think 2007-ish, cloud really starts to come up, and storage becomes cheaper because we can decouple compute from storage. You don't necessarily have to go invest in a ton of hardware and infrastructure to scale your storage. So data lakes were awesome. We start getting all of this object storage available to us. But one of the challenges with data lakes is that, yes, we are able to store more information, but the utility is difficult. You can't really tell an analyst, even today, to go into the data lake and grab those JSON files and figure out the key value pairs and do analytics on it. It's not happening. So what happens? Even today, right? We may drop data in the data lake, but then we need to do an ETL back into the data warehouse somewhere. And now we've got multiple copies of the data, and we're still just doing analytics in a separate warehouse, cloud warehouse, um, because it's for the purpose of analytics. So the data lake, while it increased the amount of data and the types of data that we could store, didn't necessarily improve the utility. It was super awesome for machine learning. Some machine learning algorithms are really great on raw data. So ML was really good in the lake, but analytics is not. So now this is a challenge that we see today with we have two separate workflows, kind of two masters that we're trying to serve at the same time and balance. The analytics workflow of OLAP and gathering lots of data and trying to do these analytics on it in a cost-effective way. It needs to be structured. And then, and that's really driving decision making, or at least it should be in theory. Right. So we've got the analytics warehouses. And then on the other side, we've got more of the transactional side. We've got the data lakes. We're doing machine learning. We're trying to do more point in time, like fraud detection, like real time fraud detection, right? So if you drop something in the lake, let's say you're taking game data from I don't know what games are out there now. Halo. Hopefully that's a game. I should start playing games so that I know what I'm talking about. If you've got real-time Halo data being dropped in the data lake, you want to be able to identify fraud or cheating like right away. Like 5 minutes later, that data is much more valuable than if you waited for a daily cron job to then analyze that data 24 hours later, right? It's not the point in time data, individual transactions loses value over time, where analytics, the aggregated data, increases in value over time. So they have different needs. But then we end up with two different storage systems, at minimum, right? We might have Postgres, and then we've got ADLS, and then we've got Fabric, and we've got all these disparate systems, and maybe we have multiple versions of these across our different business units. And if we're running the enterprise, we look down, if we're CTO or head of data, we're looking at it and we're like, oh, well, we need the warehouses, but we also need the lakes, but can we do this at the same time? Well, this is really, 2016, 2017, these are the questions that a few large companies are dealing with. So one is Databricks, right? So talking about ML, they roll out Delta Lake, and Delta Lake is awesome. And around the same time, Apache Hootie rolls out of Uber. And then about the same time, Apache Iceberg comes out of Netflix. Because think about these companies, and this is why these are a little bit different. Iceberg and Delta Lake are fairly similar. There's definitely some technical differences, but fairly similar. And then Hootie is a little bit different. So we've got all this lake data, and imagine you're Uber. What's most important to you? It's really the most recent transactions. Like, you really kind of need to know where the car is like right now versus like yesterday, maybe yesterday, but right now is more important. So Hootie really thrives on like streaming data, transactional data. And we'll look at like what is a lakehouse, but this is a table format that sits on top of a data lake. And we'll talk about what that is, but just high level, I'll break it down. Delta Lake rolls out a Databricks where they crush, manage Spark, and they're doing ML. Delta Lake is really great for that. And it lives in the Databricks ecosystem. Perfect. Iceberg rolling out of Netflix. If you think about the Netflix use case, right? They have so much data. They need to do analytics, but they also need to balance, those personalized recommendations. So what if they could have all these warehouse capabilities like ACID compliance, um, being able to get the data quickly, being able to um, support analytics, but at the same time have an object store. This is what the table format strives to do on top of a data lake, is provide data warehouse capabilities directly on the data lake. And that's really the vision of a table format, is what if we didn't necessarily need a warehouse and a lake or all these processes, and now we've got a huge data ecosystem. What if we could just take advantage of the data that's in our lake, but give it all those awesome benefits that we get from a warehouse? So atomicity, uh, all the ACID compliance, partitioning, how do we do that? Well, there's a few ways that it happens, and we'll talk a little bit about Iceberg. So going back to the deck, somewhere my deck lives. Let me find it here. So why Apache Iceberg? So Apache Iceberg is an open table format. And what it is nothing's stored in Iceberg. If you've got Parquet files, inside of your data lake, inside of ADLS, those 30 Parquet files may really be a table, but there's no really great way to see that. Enter open table format, which in the way that it's structured makes it like a warehouse where, all these files in here are really a table, and you're able to organize that. You're able to have hidden partitioning. You're able to have schema evolution and enforcement, able to have ACID compliance. And it does that in a really great way. So because it's open, right? An open lakehouse, right? Warehouse, lakehouse. This is really kind of the vision that Bill Inman had for a central repository. You can have lots of different engines working with Iceberg, Trino, Spark, Flink. You can have open table formats, Hootie, Iceberg. You can have a unified metadata catalog, open source like Apache Polaris, Project Nessie, which will likely be rolled into Apache Polaris. There's some proprietary catalogs that you could choose to use, like Glue from Amazon. But what this does for us is now we can access all of our data, right, in the lake, and we can have all those benefits that we need to manage our analytics pipelines, but we don't have to physically move it. And we have all the benefits of having the data in one spot where we can manage our AI pipelines. So all from the same place. So for AI ready data, what do we need? Well, we need reliability, right? And so if we're able to see the raw data, if we just need the raw data there, awesome, we can do it. We can do our ELT in place, or we can do logical modeling in place on ADLS, so that we can for sure see how the model was trained, what the data looked like. Apache Iceberg enables time travel. So if your AI model goes off the rails, you can specifically look back at a snapshot of the data and see, okay, when we trained this model, what exactly was that data? What exactly did it look like at the time we trained this model? Insanely helpful. Enforcing the schemas makes it very easy to work with. And if you're moving towards more of a decentralized data ownership or a federated data ownership, where now business units are starting to own parts of the data, for instance, marketing may own the marketing data. This is the whole idea between data mesh, shift left. Maybe marketing has data engineers, AI engineers, analysts on their team. Now they can work out of the data lake for their own purposes. Why is that important? Well, it helps governance and security. So Microsoft is really great at data fabric, both in the product data fabric, but also the concept data fabric, where security and governance is more centralized. So now you've got your data centralized in one place. Your data gravity can kind of live in the data lake. And now that's really great for centralized governance. And then your federated data teams who are out there building AI products, building analytics, they can reach into the data lake through that centralized governance and build their own models. So they have that autonomy and accountability, but then the enterprise is still able to maintain the governance and flexibility. So a great way to do this, a way that I'm seeing out in the field, is by implementing data products on top of a open lakehouse. So data products is, there's so many definitions of it, and often vendors have their own definition, which happens to align with the capabilities that they, roll out or that they have that they're trying to sell you. But SQL Mesh is an open source product, which is why I look at it. DBT Core is open source. So there's awesome ways to do open source data products. And a data product is essentially treating data as software and treating it with accountability, making it accessible, making it discoverable, and creating curated data in a way that immediately provides inherent value. So think if you are able to get your data gravity centralized in a data lakehouse, now we've got so much more data. Think back to the ChatGPT example of we're able to expand the quality and quantity of our data. We have that in the data lake. We can expand the quantity easy, right? We've been able to expand the quantity of data available in the data lake, since 2007, early 2000s. Quantity is not necessarily a problem, but now we can also expand the quality directly on the data lake. We don't have to necessarily have a ton of ETL pipelines shooting out of the data lake into disparate sources. We can keep it all right there, quality and quantity in the same place. That rules for a data product. A data product, when it has access to a larger amount of data and higher quality of data, with improved transparency, right? We've all dealt with it where, something goes wrong in data further down the pipeline. You really have to work backwards and try to figure out, like, at what point did this data go wrong, or did the process go wrong? And sometimes that data has been moved and transformed, a dozen times. It can be super hard. And so the observability, transparency, very difficult in a very long ETL pipeline. If you do an ELT pipeline, and you can really use both, but if you think about ELT, like transformation in place, you have to look fewer places. And if you're using a data product approach where all of the transformations are logged using software engineering style version management and notes, using GitHub to update your data product and models, much easier to find the bug in your data products. So data products and a lakehouse, an open lakehouse built on top of Apache Iceberg, works super well for powering AI. But you may be asking yourself, like, what about vector databases or graph databases or special purpose databases? And these databases really kind of exist if there's a use case that needs special performance, where these databases are going to far outperform or meet the needs and capabilities than you could have done in like a lakehouse. So, and there's definitely cases for that. Like if you need a vector database, you need a vector database. But what you can do is what I call core and explore, and I'm seeing a lot of organizations move this way. Centralizing your data in a data lakehouse using Apache Iceberg, or if you're in the Databricks ecosystem, or I think Microsoft uses Delta Lake as well, use Delta Lake, but Apache Iceberg's open. So centralize the core of your data in a data lakehouse, right? And then case by case, move to a time series database for this specific use case, move to a vector database for this specific use case. But now you're managing your data estate much more efficiently and effectively, which is awesome for the governance people. And then it also makes your life easier because you've got that flexibility to, one, the bulk of your analytics and ML and AI use cases, you're going to be able to do on the lakehouse. And then for the specialized cases, you can move to a graph or a vector or a time series database. But really, the center of your architecture is going to kind of live in that lakehouse. Simplifies it a lot. It's also generally less expensive, which is awesome. So that Corn Explorer really can help you optimize your AI. Some AI really just for sure needs, a vector database, or maybe you're doing graph rag. Perfect. But that doesn't necessarily require all of your data. So you can be strategic and thoughtful about where your data lives and manage it effectively by using open source tools. So that's really kind of the bulk of my presentation, thinking about what's AI, right? What are we talking about? What role does data play in building and training and deploying AI models and then maintaining them? Huge, huge impact, right? We need to have maintainable, robust data systems. How can you do that? You can use open source like Apache Iceberg, SQL Mesh, and then you can continuously maintain it and refine it through a data product approach. Awesome. That's what I have.
Cool. Thank you very much, Andrew. That was awesome. I really like the way that you start from, actually from very beginning, how the data story actually started and why we need, the actually highly, performance data storages and data formats like this Iceberg, Delta Lake, actually how they are going to help the data systems and AI systems. That is awesome. And how it is, and as far as I know, the actually Microsoft Fabric is going to support the Iceberg
Yep.
data format in OneLake. However, at this stage, only the Parquet and Delta tables are available, but Iceberg is part of the roadmap.
Yes.
And how we can make actually benefit from this Iceberg in Microsoft Fabric, when we are thinking about the data performance and data quality, and also how the cost is going to affect our the whole project. Of course, the storage and just transferring the data. What do you think about this section? How it is going to fit in our data solutions in Microsoft Fabric?
Yeah. So, and Delta Lake's awesome. And, Databricks, owns Delta Lake and also bought the team that created Apache Iceberg. And their vision that they've stated is to try to get rid of the differences and make table format not an issue anymore, like not having to choose between them. Currently, we kind of do. But Delta Lake, you are able to turn those into uniform tables, which creates Apache Iceberg metadata. So they kind of can play together right now, which is really great for folks using Microsoft. But Delta Lake's awesome. And in terms of cost of project, there's a few things that are helpful. So if you land data in the Microsoft ecosystem, if you're landing it in ADLS and you use Delta Lake tables on top of it, you're able to do much more with that data in place rather than continually moving it from system to system and potentially getting hit with egress fees. And now different teams own the data. And every time you ETL it, that opens you up to a data quality vector of attack, because now the data lives in a different place and they need to be synced, and every pipeline is an opportunity for it to fall out of sync. The more you can do directly on the data lake, the higher quality and the easier it is to govern. So it just reduces the infrastructure and amount of effort to create that high quality ecosystem while also minimizing like egress fees.
Okay, cool. And And, there were some questions from Sumesh that you already answered. During the session, how this session is in context to Microsoft Fabric or not. And thank you for sharing the QR code for that Apache Spark ebook. And so yeah, Sumesh just say thank you. And there's a question from Don. Any difference between Iceberg and Delta format?
There is, and it's becoming less so. Delta is currently much better at working with streaming data. If you think about how Delta came to be, right? Like Databricks, they rule at Spark, right? And so Delta Lake is really good with streaming data. Iceberg's getting there, but in my personal opinion, it's not as good as Delta Lake. In terms of the transaction model, like Delta Lake writes through writes are serialized through like transaction logs stored directly in cloud storage or distributed file systems, and that simplifies the implementation, which is why it's better at streaming. With Apache Iceberg, it does support optimistic concurrency, but the metadata is managed separately in a metadata tree, which does help for sophisticated operations on like a larger table, but it's going to slow it down in terms of reading from the stream. So there's metadata management differences. The schema evolution is a little bit different. Partitioning is a little bit different. But in terms of like performance, that's often what folks are looking at. So performance, Delta Lake offers super strong performance, but it kind of is optimized for the Databricks environment. It is open as a Linux project, but Databricks is the only one contributing to Delta Lake. Apache Iceberg's community owned, so there's lots of different companies contributing to it. So there's lots of different use cases that are being included in the Apache Iceberg contributions. So it in general, I'd say Delta Lake's better at transaction and Spark workflows, and Apache Iceberg is better at planning large analytical queries. Again, that's generalized, but kind of in general, those are some of the difference.
Cool. Andrew, in Microsoft Fabric, there's an opportunity to shortcut to Iceberg tables. When we are using the lakehouse, we can create the shortcuts. In order, we have lots of learners in our community, including myself. How we can, create, some Iceberg tables somewhere, just for doing, the hands-on experience to learn more about them, and creating these shortcuts in Fabric and start connecting to those, data storages. How you can just guide us with that regard?
Yeah, so there's a few things you can do. So the OneLake shortcuts are really great. So if you've got the data in your ADLS Gen 2, I mean, even if you've got some S3 or GCS out there, you can do the same thing. Really, it's just turn it on and start to play with it. So you want to create an Iceberg table inside of ADLS, right? And then start figuring out like how you can make it accessible to your Fabric workload, and just do like a little demo of, okay, now I've got this Iceberg table. How do I query it? How can I build an easy workflow that's accessing this Iceberg table? So you can write Iceberg tables to OneLake using different tools. You can convert them, but yeah, just getting started small, right? Like Iceberg does rule at giant tables, but that's not what I would start with. I'd start with a small use case of the table, the catalog, the query engine, and then implementing that into just like a small workflow on
Awesome.
OneLake.
Cool. Thank you very much, Andrew. I don't see any more question in the chat, guys. If you missed the session, if you joined late, for sure it is going to be available on our YouTube channel immediately. And feel free to ask your questions on LinkedIn, and you can just maybe ping uh, Andrew to answer your questions. I'm gonna just share my screen again to uh, give you some updates again. So our session with Andrew is done. Thank you very much, Andrew, for coming here. And stay tuned for our next session, which is going to be April 19th, our online session with Armando. And if you're again in Sydney, join me in the on April 8th in actually the Microsoft Reactor office in Sydney. And yeah, just don't forget to actually subscribe to our YouTube channel for upcoming sessions. And of course, you can rewatch all of the sessions that we had in the past, including Andrew's session. And on our LinkedIn page, you can always just follow us there for getting the latest updates from community and Microsoft Fabric, as well as Microsoft Learn. And don't forget to rate our this session on the meetup. And yeah, we have some comments here. Great session. Thank you, Sheila, for attending. Andrew, if you have anything to add, feel free. If not, we can just wrap it up. And just wishing you a great weekend. My weekend actually is in the half now, but
Yeah,
you're
you're already in your weekend. Yeah, no, we can wrap it up. Just feel free to connect with me on LinkedIn or in the Slack channel. Happy to continue the conversation and get a little more in depth with you in those
awesome.
areas.
Awesome. Thank you very much, guys. Enjoy your weekend and catch you later. Cheers. Bye.